Hi everyone. Today we're going to study conversion of solid from one shape to another. Surely you would have seen candles. Generally, they are in the shape of a cylinder. You may have also seen some candles shaped like an animal. The question is, how are they made? If you want a candle of any special shape, you will have to heat the wax in a metal container till it becomes completely liquid. Then you will have to pour it into another container which has the special shape that you want. For example, take a candle in the shape of a solid cylinder, melt it, and pour whole of the molten wax into another container shaped like a rabbit. On cooling, you will obtain a candle in the shape of the rabbit. The volume of the new candle will be the same as the volume of the earlier candle. This is what we have to remember when we come across objects which are converted from one shape to another, or when a liquid which originally filled one container of a particular shape is poured into another container of a different shape or size. Example 1. A cone of height 24 centimeters and radius of base 6 centimeters is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. We know that the volume of sphere equals volume of cone. Let us show the formulas for each. For the volume of sphere, that is 4 over 3 pi r cubed, equals the volume of cone, that is 1/3 times pi r squared times h. In the given, we have the data for the cone, so we substitute it here. The radius is given as 6, then we square it, and the height h is 24. Let us simplify the cone's volume. 6 squared times 24 will be 864. And from here, we're going to solve for the radius of the sphere. We can cancel the pi and the denominator 3. Then we isolate r cubed. That will be 864 divided by 4. The quotient is 216. Then the value of r is the cube root of 216. When we simplify this, that is 6. And the unit of measurement is centimeter. Therefore, the radius of the sphere is 6 centimeters. Example 2. Selvy's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, an underground tank, which is in a shape of a cuboid. The sump has dimensions 1.57 meters times 1.44 meters by 95 centimeters. The overhead tank has its radius 60 centimeters and height 95 centimeters. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. Use pi equals 3.14. The volume of water in the tank, which is a cylinder, is equal to the volume of water removed from the sump, that is a cuboid. Now, the volume of water left in the sump after filling the tank equals volume, that is the cuboid sump, minus the volume of the cylinder tank. Let us show the formulas. For the volume of cuboid, that will be length times width times height, minus the volume formula for cylinder, pi r square h. Let us substitute the corresponding values with respect to meters. For the volume of the cuboid, we will have 1.57 times 1.44 times 0.95. This 95 centimeters is now shifted as 0.95 meters, minus pi is 3.14 times the radius, which is 60 centimeter. We write here 0.6, that is squared, times the height of 95 centimeter. We write here 0.95. In the second group here, the 3.14, we can factor it out as 2 times 1.57. Now look at the two groups. There are common factors. The values 1.57 and 0.95 are common. We can factor it out. What remains in the first group is 1.44 minus, in the second group, the remaining values are 2 times the square of 0.6. We simplify the product. 2 times the square of 0.6, we will get 0.72, and the difference inside the grouping symbol is 0.72. And for now, with this is in cubic meters, this is our volume of water left in the sump after filling the tank. Let us copy these values near this volume. Now let us go for the height of the water left in the sump. The formula will be volume of water left in the sump divided by length and width of the sump. In the numerator, we derive this value from the previous computation, so we substitute it here. While in the denominator, that will be length 1.57 times the width 1.44. Let us simplify this fraction. We can cancel the 1.57, and with the use of our calculator, the quotient will be 0.475. That is in meters. We can convert this into centimeter as 47.5. This is the height of the water left in the sump. Example 3. A copper rod of diameter 1 cm and length 8 cm is drawn into a wire of length 18 meters of uniform thickness. Find the thickness of the wire. So the volume of wire is equal to the volume of copper rod. Let us evaluate the volume of copper rod. The formula is pi r square times h. In the problem, we have diameter given as 1 centimeter, and we need the radius. That means radius is 1/2 centimeter. Let us now substitute this value for the r. So that will be pi times square of 1/2 times the height, which is 8. We simplify the square of 1/2 to be 1/4. Then we cancel this 8 by the denominator 4. Final answer is 2 pi cubic centimeter. This is the volume of copper rod. Now, the volume of wire. The formula is also pi r square times h. With the idea here that the volume of wire equals volume of copper rod, this is the volume of copper rod that we can substitute for the volume of wire. So we have 2 pi equals pi r square h. Then we solve for the radius r. We isolate the r square, so that will be 2 pi divided by pi times h. We can simplify this by cancelling the pi. Then the value of r will be the square root of the fraction 2 over h. Now, this h is the height. And in this problem, for the wire, this is equal to the length given as 18 meters. We convert this 18 meters into centimeter as 1,800. Then we substitute this 1,800 to the h. So it becomes like this. We simplify the fraction as 1 over 900. Finally, the square root is 1 over 30. The problem requires the thickness of the wire. In that case, it refers to the diameter of the wire. We have the radius computed as 1 over 30. That means we multiply this by 2 to get diameter. So 2 times 1 over 30, that will be 1 over 15 centimeter. This is the thickness of the wire.